Good morning, students. Today we are going to learn about enzymology. Enzymology is a major part in biochemistry and it deals with study of enzymes and study of mechanism of enzymes and application of enzymes. And in your syllabus, okay, we are going to have about the classification, nomenclature, and the mechanism of enzyme and enzyme kinetics. Both the type, okay, reversible and irreversible type of enzyme kinetics and mechanism and derivation. Mechanism of enzymes, we have the example, okay, lysozyme, okay, with all the components will be covered, okay, within enzymology, and we can have one by one. The first one is the classification nomenclature of enzymes. So this classification depends on the rules and regulations framed by the committee, okay, that is International Union of Biochemistry and Molecular Biology. Okay, this is the organization. So this organization frames the rules for the classification of enzymes. And next one is the 6 different types of classification. One is oxidoreductases, second one is transferases, hydrolases, lyases, isomerases, and ligases. All the 6 different types. And usually the name of the enzyme, okay, that is for example hexokinase. This hexokinase, there are 2 different segments, okay, in the name of the enzyme. That is, hexose means it represents, the prefix is hexose, okay, that means it is substrate. It is representing the substrate, and the second part is the function of the enzyme, and ends with the end of the word, okay, that is ase, is common for all the enzymes, okay, that is represented here, okay, the suffix ase, and all the information, okay, given here. And example, okay, here I give malate dehydrogenase. So this malate dehydrogenase enzyme, okay, which is involved in the conversion of malate to pyruvate in the presence of NAD plus, and the pyruvate plus carbon dioxide and NADH is formed here, okay. And the common name is malate dehydrogenase, and actually, okay, based on the IUPAC classification, the name of the enzyme is L-malate, okay, this one, L-malate NAD oxidoreductase. Okay, these are the 2 different types of names. Okay, one is the common name is malate dehydrogenase, second name is L-malate NAD oxidoreductase. Okay, this is the official name, okay, based on IUPAC. So coming to the nomenclature, so this nomenclature is naming the enzyme. Okay, this enzyme nomenclature based on the EC enzyme commission number. Okay, this enzyme commission number, okay, having 4 digits. That is, for example, here, so we can have so this is the example, EC 2.7.1.1, that represents class 2. So the first digit, the 2 represents the class 2. Class 2 means class 2 means a transferase, the major type, and second, that is 7, that is subclass, and 1 represents subclass, and the last one represents the name, the final name, okay, that is hexokinase. So this is very simple, and this is also very important for the examination point of view. And the next one is so this is a ratio of the total 6 different types. So the recently, okay, the IUPAC released the database, and the total number of database is classified into 6 different types. The majority the comprise, okay, in the hydrolases is 65%, and the first type is oxidoreductase is 25%. Second main class transferase is okay, that is 5, and third one is 65% is hydrolases, and lyases is 5, and isomerases is 1%, and ligases is 1%. And so coming to the major different types, oxidoreductases involved in the transfer of electrons, and here the example is given, A minus plus B gives A plus B minus. Okay, here the electrons are transferred from A to B, so that is why B will receive electron. Okay, that is why it is called as B minus. The example is alcohol dehydrogenase. Next type is transferases, transfer functional group. AB plus C gives A plus BC. That means so this C will be joining with B. So A will be separated, A plus BC. Okay, that is hexokinase, this example. And hydrolysis reactions. So that is in the presence of water. So water is having H plus and OH minus. So H plus will be joining with A. So AH will be formed and B will be forming BOH. Next, fourth type is lyases, the cleavage of bond between carbon-carbon and carbon-oxygen and carbon-nitrogen and other bonds, often forming the double bond. Okay, that means any bond cleavage involving reaction is called as lyases. For example, so this bond is broken down. Okay, this is X A between A and X and B and Y. Okay, that is broken. Okay, the A double bond B is formed and remaining X Y will form a bond. Next one is isomerases, the formation of one isomer to another isomer. The best example is okay, this one. Okay, that is glucose isomerase, the glucose to fructose and fructose to glucose. And ligases, the bond formation, and A plus B gives AB. So this is formation of bond. Okay, and previous one lyases, breakdown of bond. So this formation of bond, okay, requires energy. That energy is given by ATP hydrolysis, that will give the energy. So within this we can complete all the 6 different types of enzymes. And next one is active site. Active site is nothing but the binding site of substrate to the enzyme is called as active site. So that is why active site is very important, because actively involved in the reaction. That is what is called as active site. The active site of an enzyme generally a pocket or a cleft. Okay, that is placed on the surface or otherwise placed in the gorge of the enzyme. Okay, and this interaction depends on the charge. Okay, that is hydrophobic interaction, and if it is charge, electrostatic interaction, and hydrogen bonding, and van der Waals forces. So all the 4 interactions are very important to form the binding of substrate to the substrate binding site. Okay, that is active site on the enzyme. And this is the example between the chemical catalysis and enzyme catalysis. You can see here the black line. Okay, this line indicates the chemical catalysis, and this line, okay, this is called as the pink color line. Okay, that is enzyme based or enzyme mediated catalysis. You can see the difference. Okay, this is the formation of the product. So this is the product, y axis, and x axis is the time. Okay, that is in seconds or hours. So these product formation is very slow. Okay, in chemical catalysis. In the case of enzymatic catalysis, it is a steep increase in the enzyme product form. Enzyme catalyst reaction that will form, okay, more product formed, okay, within a short span of time. So that is the difference of enzyme and the chemical catalysis. Next one is coming to the enzyme, that is the energetics of enzyme kinetics or otherwise enzyme catalysis. So the dashed line, okay, here, so this represents, okay, the enzymatic reaction, and the straight line, okay, that is without any dots or without any breaks. Okay, that line represents the formation of substrate to a transition state and a product. A substrate is converted to a product, okay, and the transition state is in between state, okay, between the substrate and the product formation. And to form that particular state, okay, this much energy is required. So this is 0 level energy, and from to this level, and we need this type of energy. This amount of energy is required. That is why. So this is for delta G for uncatalyzed. Okay, this big arrow mark, and small arrow mark will be given delta G for catalyzed reaction. You can see the difference. For non-enzymatic reaction, more energy is required to form, to change the substrate to the product similar form. Okay, that is transition state. And in the case of enzymatic reaction, okay, delta G is very less when compared to uncatalyzed reaction. So that is why enzymes are very highly energy efficient, and enzymes decreases the activation energy. The activation energy is less than compared to non-enzymatic reaction. Next, coming to the different types of enzyme, apoenzyme and holoenzyme. Apoenzyme is nothing but the protein part of the enzyme, and holoenzyme is apoenzyme and other cofactors involved. Cofactors are nothing but metal cofactors or organic cofactors. Organic cofactors are called as coenzymes, and metal ions are called as cofactors. So we can classify this one. Now the terminology, that is based on the framed regulation of Enzymes Commission, that is IUPMB. The cofactors is a common terminology. So we can classify this cofactor into essential ions and coenzymes. Coenzymes, which comprises the organic molecules, further classified into co-substrate, loosely bound and tightly bound. And tightly bound is prosthetic group, both comes under coenzyme category. So the essential ions, that is the metal ions involved here. The activated ions are loosely bound and tightly bound. Tightly bound is metal ions of metalloenzymes. And this is the common terminology now. Previously, the cofactors represented for metal ions and coenzymes represented for organic molecules. Now this is the new terminology and the new type of regulations that are given by IUPAC. So we have to follow this one. And so these are the examples of cofactors and metal ions. The coenzyme, the thymine pyrophosphate and flavin adenine dinucleotide, that is FAD, and nicotinamide adenine dinucleotide, that is NAD, hydroxyl phosphate coenzyme E. These are the examples of coenzyme, and these are next column, that is pyruvate dehydrogenase enzymes involved in the coenzyme formation. Metal ions. So here some of the metal ions are given: zinc, Zn2+, Mg, magnesium 2+, and Mg2+, nickel, molybdenum, selenium, manganese, and K. That is potassium. The examples are given, so remember all the enzymes involved in this. So in the next table, we have the dietary precursor in the mammals of coenzyme. That is the coenzyme. Biocytin is the name of the coenzyme, and biotin is the dietary precursor in mammals. The main function of biotin is the carbon dioxide transfer. This is an example of chemical groups transferred here. I mentioned this one. So this carbon dioxide is transferred by biocytin. This is a coenzyme. And dietary precursor in the mammal, the name of the dietary precursor of biocytin is biotin. So similarly, you have to remember, so this column, and this column. And this is some enzymes, some coenzymes that serve as a transient carriers of specific atoms or functional group. Here CO2, acyl group, hydrogen atom, electron and acyl group, hydride ion, amino groups, one carbon group, tetrahydrofolate, THF, that is very important in nucleic acid metabolism. So one carbon group carrier and aldehyde carrier. So with this, we can complete all the different types of enzymes. That is including the 6 major classes and the nomenclature and everything. So with this, we can complete this lecture 1 of enzymology, and so we can have the next step in the